We'll talk about different coordinate system in mathematics or calculus. So coordinate system are kind of, it is a pillar that is the backbone of any calculation. Not only coordinate system, we will talk about interoperability among the coordinate system. I am a program or I am a hardware engineer and I enjoy I enjoy designing electronic circuits. I am a hardware engineer or hardware person, then I enjoy designing electronic circuit. Now, when I enjoy designing electronic circuit, then I have drawn a electronic circuit for a particular purpose. Now, part of the circuit, I believe that if I take from other circuit, may not be belong to me, someone else, and attach it here, then it would perform better way. Now there is interoperability between two circuits, interoperability between two coordinate systems. Not only we will talk about a coordinate system, we will talk about interoperability between the coordinate system among the coordinate system. We can call it hybrid model also. So hybrid items typically they are kind of sweeping the world. Hybrid items. If I have copper, very nice. If I have iron, very nice. And if I have alloy, very nice. But whatever, I mean, copper, aluminium, and iron, very nice. But if I create alloy, then it has all the three characteristics and plus it has its own peculiar characteristics. So alloy, so hybrid model interoperability, we will see. I will not go in the interoperability as far as human races are concerned because that will be something that is inappropriate here. But alloys or hybrid model, if it is in controlled fashion, so that is the biggest problem with the hybrid model. If you create a lot of hybridization, hybrid model, then probably after a point you cannot control it. So that is the concern for the hybrid model. If you go with infinite hybrid model, then your energy level should be infinite, then only you can control it. So what is the best model? Best model is a model that you can control, that gives the minimal output and it sustains for years rather than I'm going for very complex output, very nice output, okay, but start sweating getting the output, and when I get the output and then it, if there is some problem, then it takes lot of time or it is out of my control to fix it. If I fix it, then it takes lot of money, lot of effort. That is, but once I fix it, then it gives very nice output. But if it goes wrong, then it becomes nightmare. That is hybrid model. So things should be under the control. Okay, if God has made universe where earth is not even a single drop in the ocean, then God knows how to control it. Okay, so if you design something, then you should be aware that I have to control it. That is the biggest thing. If you cannot, why God did not make universe that is bigger than this? Other, I believe he would not have controlled it. Why God did not make universe that is smaller than this? Because it would have been easy for him to control it. He would not have enjoyed it. So this is the balance that you have to keep. Anyway, so Cartesian coordinates. Cartesian coordinates, any Cartesian coordinate. There are many Cartesian, oh sorry, the kind of coordinate system in mathematics or algebra. Cartesian coordinate is one of them. Polar coordinate, cylindrical coordinate, and a spherical coordinate. At least I know this much. So polar coordinate, cylindrical coordinate, a spherical coordinate, Cartesian coordinate. what is similarity among all the coordinate system? All are different. That's why there are other so many coordinate systems. But similarity is there are orthogonal components. What is orthogonal component? Okay, what is orthogonal component? I have something in my hand. Okay, this big. Okay, I have this in my hand. Okay, if I have this in my hand, it has a color. I'm not going in calculus. People would start kind of unnecessary. They would start kind of frightening. So this has a color. Wood color. I don't know. It is reddish, maroon, or whatever. It is wood color. This has a color. Now, if I change this color, if I bring change in this color, then is it all right? If I keep changing the color, it's okay. Like I'm staying in a house and sometime I come in night, sometime I go early morning, sometime this, sometime that, sometime I booze up. I mean I don't drink, but sometime I drink and sometime I smoke. I don't smoke, but sometime I smoke. Okay, sometime I do good things, sometime I do bad things. Okay, I'm changing. But who on who I am giving the pressure? Pressure comes on someone in the house. He is kind of taking care of you. Okay, someone is sustaining your pressure, human wise, architecture wise, like building wall and building full construction. It is taking the weight, whatever the changes you are bringing in yourself, and the old people or whoever is kind of pillar stone of the family. They are they are taking your load, unnecessary load. Okay, so don't do like this that much. But whatever the people, the entity which is taking your load, this is coordinate system. So if I talk about color, changing color, then which one is taking your load? Red, green, and blue. There are three colors which is taking your load. Whatever changes you are making, accordingly three component they change. If you change red, then green and blue has nothing to do with it. If you change green, then blue and red has nothing to do with it. But if you change other color like yellow or wood color, whatever, then one or other other component of RGB would change because the color technology sits on orthogonal component that is red, green, and blue. If I talk about Cartesian coordinate, then each coordinate I take, they sit upon the kind of orthogonal component, they sit upon the orthogonal component that takes the pressure of the coordinate system in x-axis, y-axis, and z-axis. So that is the Cartesian coordinate. They are why they are called orthogonal to each other, and they are taking load of this Cartesian coordinate. So what is Cartesian coordinate? Okay, I have so many items. Okay, Cartesian coordinate is there is a line like this, then there is another line perpendicular to it, and then there is another line. It is a straight line perpendicular to it. Now there is not possible that there will be another perpendicular. So if you see, all three are perpendicular to each other. Okay, and they are called x-axis, y-axis, and z-axis. Now consider a vector that is 2i plus 3j plus 4k, or there is a vector in xy plane. If this is x-axis and this is y-axis, this is Cartesian coordinate. If it is x-axis and it is y-axis, then both are independent to each other. Independent to each other means if I grow in x-axis, it does not give any effect on the y. If y grows in its y-axis, it does not give any effect on the x-axis. But there is a vector u. U is nothing but 2i plus 3j. If this guy is vector is nothing but energy which has a direction and magnitude. So x-axis, if I say I vector, then it's also a vector which has a direction along x-axis and magnitude is 1. J-axis magnitude is 1, but it is 90-degree orthogonal. This degree, these are very small things. Okay, don't go with degree. Main thing is that is whatever you are doing, which component they are taking your load. In machine learning, the features, the so many features are there, they are taking load of your data set or each document vector. Okay, here axes are taking your load. Okay, now if I have a vector 2i plus 3j in xy plane, if I have a vector like this, then if I say that my vector is 2i plus 3j, now it is 4i plus 5j. My vector is independent of x-axis and y-axis. Not possible. If vector is not orthogonal to x-axis and it is not orthogonal to y-axis, means it will impart pressure on x-axis and y-axis. If it is 2i plus 3j, then it is imparting pressure on x-axis as 2 and y-axis as 3. I mean, if it is an energy, vector is an energy, then this energy 2i plus 3j, then 2 magnitude of energy is sensed along x-axis and 3 magnitude of energy is sensed along y-axis. If there is a vector which is 10j, then 10 is the magnitude of the energy and it is in y-axis. How much energy is sent along x-axis? Nothing. That is orthogonal component. Orthogonal component, if I place energy vector along one component, then other component would not sense any essence of the energy. But if I have a vector 2i plus 3j, then certainly 2 is the magnitude of the energy that is sent along x-axis and 3 along y-axis. This is the scenario of coordinate system. Cartesian coordinate system, all pressure. If I go from 2i plus 3j to 4i plus 5j, then x-axis is getting 2 more pressure and y-axis is getting again 2 more pressure on it. Or I say that to double strength of energy, 2 unit of energy is sensed more, that is 4 now, along x-axis and 2 more is sensed along y-axis. Along z-axis, no energy is sensed. Okay, so this is the kind of analogy, bisection, trisection or quad section of coordinate system. If I have anything in the coordinate system, if I start changing it, then this change pressure goes upon which backbone? The backbone is the orthogonal component. If my machine learning data set, its pressure is going on, pressure generally, it goes on all the features. If there are 1000 features, then full data set, it is aligned on, or it is kind of bent upon, its load is bent upon 1000 features. Is it possible that data set features, data set is, is kind of lying upon giving the weight on the feature? Is it possible that this feature can give weight on something else? If it is data set is 10 million in number, document vector, but it is giving pressure on 1000 features. Can 1000 feature give pressure on only 3, only 4, only 10? Then it's fine. This is called direction reductionability. So if I go for this is called dimension. This is called dimension reductionability. Means we are reducing the dimension in this fashion so that few components would take your load. So if you understand the concept of load, then you can come up with different kind of coordinates. Now Cartesian coordinate system is a way where x-axis, y-axis and z-axis they take the load. Okay, but in physiology, in physical way, they are different by angle. Pi by 2, that is 90 degree, and then pi by 2 from these two. So it makes many planes: xz plane, yz plane, xy plane. Okay, so this is the scenario of Cartesian coordinate system. What about other? I'm not talking about interoperability right now. What about other coordinate system? There is another coordinate system that is called polar coordinate system. Polar coordinate. Polar coordinate system in a way that whatever I am seeing, it is varying in a circular way. If I have a vector like this, then a vector changes like this, vector changes like this, vector changes like this, then I feel that the pressure what it is giving with the change is like Cartesian coordinate. There it is giving the pressure. If my vector is moving like this, then where it is fixed at one position and it is making a round, okay, then this length decreases, okay, where it is making the change. One change is that it earlier it was small and suddenly from a small it grew up like this. So one change it is giving in this direction. This is the change I am seeing. So the length of this stick is changing. Sometimes it becomes this, 0, then sometimes this, or whatever the length it carries, then with fixed point, it start doing like this. I was rotating like this, it start doing like this. It doesn't look like Cartesian coordinate where there is a fixed point and it start moving like this. I mean, I can say it makes angle with the x-axis and angle is keep on changing. Okay, then it makes angle with y-axis again keep on changing. Then x-axis again keep on changing. How many factors are coming? X-axis, y-axis. But if I say that there is only entity that is changing is angle, there is nothing more than that. So there are only two entity that changes. Either this stick changes in length or angle is changing. If that is the scenario, then there are whatever the changes I am bringing, the load of the change is going on upon two backbone. One is the radius and another is the angle. So orthogonal components are angle and radius. This is polar coordinate system. So whatever you are doing, try to find minimal backbone amount. If I think about Cartesian coordinate, if it is moving in this fashion, then three places I have to think about the load. Four places. One is x-axis, y-axis, z-axis and the angle. But if think about other way, polar, then only two places it is giving the load. One is radius and another is angle. One is one is radius and another is angle. Radius and angle. If these two are there, then it is taking the complete load. If these two people are taking complete load, then why I should pay to other people who are taking care of me? Because they need resources and money also, right? I am not talking about home relatives who take care of our load. Okay, they give us money or whatever, they take the load. But generally, like any friendship or anywhere else, so I have to keep people or office or wherever where people take the load. So there, why I should bend upon too many people? Why a database feature has to be 1000 in numbers? I can reduce it because it needs maintainability, it needs cost. So if something is moving that is fixed at one point and like this, and it is moving also, and size of this stick is is variable. If only this much is the scenario, then polar coordinate make more sense. What about that it may change the radius, it may rotate like this, and there is a vertical component also that would change. So this is 2D. Whatever we are talking, radius and angle, two variant, it is called two dimension. What about there is another variation along height, kind of hybrid of Cartesian z-axis and then polar coordinate. So polar coordinate and Cartesian z-axis, something like that. But anyway, can I extend this polar coordinate to 3D? If I want to extend this polar coordinate to 3D, one way is I'll grow in the height. So it would form like a cylinder. So now, if it is varying along height, it is varying along stick, and it is varying along angle, this is the only way in a cylinder the items can vary. Only three ways. So there are three backbones who are taking care of the load: radius, angle, and height. They are independent to each other. At any height constant, I can make the change in the angle. Height is not changing. Or uh, with any radius constant, I can make the and change the angle, or at any angle I can change the stick length. Angle is fixed, height is fixed, but the stick length is changing. Or radius is angle is constant, radius is constant, but height is changing. This is called orthogonal component. So this is cylindrical component, radius, angle, and height. Now I have polar coordinate. Again, come back to polar coordinate. So we have now Cartesian coordinate, we have Cartesian coordinate, we have polar coordinate, we have cylindrical coordinate. Now we will have one more. Now I have a circle. This is polar coordinate. If this is a polar coordinate, then there is a radius. Radius is rotating centered at the center. If that is the case, then this is two dimension. Can I grow it in 3D? Rather than a circle, can it be sphere? So it is not very much similar that I am extending polar coordinate in 3D, like extended polar coordinate to 3D as far as cylindrical coordinate system is concerned. But here I am thinking about similar thing in 3D. If that is true, then it makes a sphere. If it is a sphere, then how I can think about the independent component or backbone upon which I am giving the pressure. What are the variables? What are the variables? One variable is that if it is the suppose there is a sphere. I really have a sphere. Okay, suppose this is the sphere. If this is the sphere, then cut if I if this sphere is centered at the origin, this sphere is centered at the origin. Okay, so center of this sphere, that is that if I go from here, Okay, what is center of the sphere from equatorial? I believe equatorial is the line Cancer, equatorial, and Capricorn. There are three lines on the earth. Okay, if from equatorial, if I go deep, 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 and I stand at a place, don't go because it is very hot inside it. So if I stand at a place and I see all equatorial line at same distance, then it is center of the earth, like this center of this ball. Center of this ball is at origin, at some origin point. Now, okay, now we're talking about what are the variables here. Now, if I make a slice at middle, okay, if I make a slice at middle, then that slice is nothing but one plane comes. That is a circle. So there is a, if there is a circle, then there is an angle and radius that is variable. If I make a slice on top, again there is a circle where there is a radius and there is an angle. Okay, this is one thing that I am seeing. So angle, if I see angle, it is 2, it is 360 degree. If I cut it here, it is 360 degree. If I cut it here, it is again 360 degree. So angle is variable, but it is same everywhere. So looks like this is one candidate which is good for backbone. Backbone in the sense that everywhere it is 360 degree. Radius doesn't look like, because if I take the circle everywhere, the radius is different. If it is different, it cannot be a backbone. So my that radius concept gone. What can be another backbone? So if I am at center, if this is ball has a center, if I fix this at center and touch the portion, outer portion of this has curvature. So if it is a center and touch the curvature, and then if I start rotating, it is rotating and it is touching everywhere. Okay, this radius looks like a backbone. Okay, so backbone, so it is changeable in the kind of everywhere. What it is changing? One is this is changing. If this is changing in this fashion, then this is changing on every slice. There is a variable that is called angle. If it is changing in this direction, then again there is a variable that is angle. And third thing is that this stick would vary in its size. So sphere will come smaller, bigger. So sphere can come smaller and bigger. One way sphere can make change. Other change a sphere can give is that this radius is changing in this fashion. Then it makes angle with the vertical. And this radius changes in this fashion. Then it makes angle with the some horizontal line. So there are three components that we are seeing that are kind of backbone here. One component is angle. If it is vertical, then one component is angle from the vertical. So that radius is changing in this plane. Okay, if this is horizontal, then radius is changing along horizontal. This angle and this angle, two angle, and then radius itself. Radius, okay, radius which is changing in this plane, and the radius it is changing in this plane, but both radius are same. Okay, if both radius are same, that radius we are talking about. So it is sitting upon three independent orthogonal components, that is angle from vertical, it is also called phi, an angle in the horizontal plane, I make cross section, that angle is called theta, and this is called radius A. Now all three are independent. How they are independent is, now if if I make a cross section anywhere, at equatorial I am making the cross section. Now it make a theta angle here. Now theta is constant. It will be like this only. Radius is constant, it will not change, but still I can change phi. So phi can change without making change in radius and theta. Now phi is constant, radius is constant, but still it can make change, that is theta. So there is a cross section I can make and theta can change, whereas phi and radius, I believe this is better answer. So it can move in this fashion where radius is same and angle from vertical is same. Now from vertical it is same and in horizontal it is same. Theta is, or if I say this is the theta and then this is the phi. Phi and theta are constant, but I can keep changing the radius length. So sphere size would become become like this, or a sphere size can become a football, soccer ball. So three components can change independent of each other. These are the three basic components that we can see. They are changing, they can change, but they do not impart pressure on anyone else. Other than this, whatever we think, they impart pressure on all of three, any of three, or any two of the three. So these three components, the sphere radius and cross-sectional angle and then vertical angle, these three are independent components which takes the load of this any variation that happens in sphere. If I know all this, then I can do various measurements in the sphere, like surface area, like volume of the sphere, like many different things I can do, because or whatever the variation I am seeing in the sphere, whatever the variation I am seeing in the sphere, those variations, after all, it will end up in these three backbones. If I take cylindrical coordinate, then it will sit on the equator, the anywhere the radius is same anywhere. If you take the cross section, radius is same. Radius, angle, and height. Polar coordinate only two dimensional. So radius and angle. And Cartesian coordinate, then it is x-axis, y-axis, z-axis. Which one is the best? Okay, yes, certainly there is best. Which one you know best? The best thing in the world is what is your native, what you understand best way, that is the best for you, because at the end you have to solve the equation. If your native is Cartesian and you are able to solve the problem through Cartesian coordinate, then Cartesian coordinate is relative. If someone is very good in cylindrical and he solves the problem through cylindrical, if someone is very good in spherical and he solves the problem through spherical, what is what is better than this is LOI, interoperability, or cross, that is not a good word, but whatever it is. So if I create a hybrid model of it, that is the better than anyone. But complexity will grow exponentially when you go for hybrid model. Okay, so there should be a question. I believe people may not. You can try it. Like suppose I have a hemisphere. I have a hemisphere. Hemisphere means if I cut down, if I cut down, this is centered at the origin. If I cut down exactly in half and lower portion I discard it, only upper portion I keep it. Then upper portion is the, it's a famous question. It's not my question. Upper upper portion is hemisphere, and that is nothing but that is a water tank. That is a water tank. Now This has radius, sphere has radius of a, small a, and water is filled up to level height h, small h. Okay, so there is a land, flat land. On top of it there is a hemisphere, half part of the sphere. That is a water tank. It is kept somewhere. Okay, flat and then hemisphere. Now with motor, someone has filled the water. Now he has seen that water has reached a height of h. If this h becomes a, then tank is full. If this becomes a that is radius, then tank is full. But it went till h level only, and he stops the motor, or water is coming from somewhere else and it is being purchased. If it is being purchased per cubic meter, then how much is the amount of water that is stored there? For that he need to pay. That is the question. Okay. Now the solution for it can be through cylindrical coordinate system. Cylindrical coordinates. That is the hint. Or it can be through a spherical coordinate system. But it will give some air blow on person who thinks in both coordinate system, because naturally, by nature, it looks like a spherical coordinate, not cylindrical coordinate, because it's a sphere and it has full-blown radius. Then if I take inside that h height, then it has nothing, because water is inside the, it's inside the, like a spherical curvature inside the tank, and there is a height h where everywhere radius is a. How much water, the volume of water that is kept. So this should be solved naturally through a spherical coordinate system. Someone should try solving it through a spherical coordinate system. Next is that can it be solved through cylindrical coordinate system? Cylindrical coordinate system, radius is constant. If a cylinder is there, water is filling up, then radius is constant everywhere. Angle is 360-degree everywhere. If it is a cylinder, only height is growing. But if it is a spherical hemisphere, then angle is 360-degree of the water, okay, theta, but phi is changing. Okay, so at some limit there is a phi angle. If it is full, then phi is 0. But phi is going and sticking at some level, and that level height is h. And then this radius is constant. It is same there also. But if I talk about the top cross section where the water is, then again the theta is 360-degree. But at that moment, the radius is different. Okay, height is h, and this radius, the radial radius is a, whereas this phi has some angle. Okay, accumulate everything, then calculate how much water it has. I can give questionnaire in kind of surface area, but volume is all right. Now, if I talk about cylindrical, then it is a curvature, not the straight what we think about the cylinder. Can we see that this curvature is changing, means radius is changing completely against the cylindrical coordinates. Radius will not change in cylindrical coordinates. If you see the radius will be smooth. But radius is changing, becoming smaller, 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 smaller. But it is controllable. This is a hybrid model of cylindrical and spherical, where this cross section radius is changing, but it is controlled fashion. It has equation with h and a. This much hint I give. So if I have cylindrical coordinate system which has radius constant and then angle is 2 pi, that is constant, only height is changing, then I can calculate the volume. But radius is slowly, it is decreasing, and it coming to a level where water stops, there is a radius. But this radius is related to the net radius, what we are talking of the sphere, and height. So it is in function of h. Okay, so generally what we do is, if I integrate this for cylindrical, then theta if I integrate theta, then 0 to 2 pi, radius 0 to a, and height 0 to h, where it is filling. Now, radius is not 0 to a because it is not constant. A is changing. This radius of the cylinder, everywhere it is becoming smaller, small, small. So if I keep this radius as a function of height, then problem solves. Okay, there if you think about, radius is same, angle is 2 pi in a spherical coordinate, only phi is changing and it is coming to level when it is height. Be careful that you are calculating a volume of a cone. I mean, you're leaving if it is a full water is there, if you make calculation, then from here till down, it is making the calculation. This portion is left out. It is not that straightforward there also. Okay, so this is questionnaire. So that you have to calculate the volume. How to calculate the volume? What is interoperability, and how to calculate surface area, that we will see.